myself Sognil sir. We have started lecture series on previous year question which is from NDA and NA 2021 question paper. I already uploaded plenty of the videos on my channel. So if you wanted to see this video, you may check it into my playlist. So here in my today's video, I'm going to explain to you all one of the question. It is from National Defense Academy, Naval Academy previous year question paper, which is from 2021 latest question paper. Okay. Now let's get started our today's question. I will explain to you all first of all question and then we'll go for the detailed understanding of solution. Here in our question, we have given question if P and Q are the non-zero roots of a equation. Okay, so we have given one more quadratic equation and that quadratic equation is having two P and Q non-zero roots. So quadratic equation, it says that x square plus px cube plus q which is equal to 0. Then we want the value for how many possible value can q have. Okay, so how many possible value can q takes. So we have to find out the possible value for q which is coming from our quadratic equation. Okay, and our option, it says that that first option, it is nil, that means q do not have any roots. Option number B, it says that q is having only one root. Option number C, which is saying that q is having two roots, and D option says that q is having three roots. Okay, now let's get started on today's solution. We'll see which one of the option is correct. So here in our solution, we have given quadratic equation x square plus px plus q which is equal to 0, and the p and q are non-zero roots. Okay, p and q are roots of our quadratic equation, but which is a non-zero. Okay, that means p and q both are non-zero and both are the roots. Okay, both are the roots of quadratic equation. Okay, both are given the roots of our quadratic equation. Okay, so p and q are roots here, and we know that sum of two quadratic roots of our quadratic equation or multiplication of a two quadratic root of our equation. So we have to apply this result over here because in our option we want the roots of for q. Okay, so what is the possible value for q which is coming here? Okay, so we know that the sum of two roots. Okay, sum of two roots, when we have quadratic equation ax square plus bx plus c, then sum of two roots, it can be like that minus b upon a. Okay, and product of a root is a constant term, that means c upon a. Okay, that means when we have sum of two root, if I consider p plus q, p and q are the two roots of our quadratic equation. Okay, p plus q, sum of two roots can be written as minus b divided by a. Okay, so compare this equation with the standard form of quadratic equation x square plus bx plus c which is equal to 0. Okay, this is the standard form of quadratic equation. Compare this with this. Okay, and sum of two root, it says that the addition for two roots is a minus b upon a. That means minus b upon a, that minus p upon 1. Okay, so it gives minus p upon 1. Okay, understood how it is coming? Because we have to apply x square plus bx plus c which is equal to 0 to our given quadratic equation, and we use the result sum of two root is a minus b upon a, that means minus p upon 1. Okay, and one more result, multiplication of a two root. Okay, or product of a two root, that means p multiplied by q which is a c upon a. Okay, that means c upon a, that means c constant term what we have here, c is a q. Okay, c upon a, that means q upon 1. Okay, so here it is easier to find out the value for p and q. Okay, so how can we find the value for p and q over here? So go for the further calculation over here. So what we have here, p into q which is equal to q, that means p multiplied by q minus q which is equal to 0. Okay, take positive term here. So take again negative q common from here, so p minus 1 which is equal to 0. Okay, so q common from here, so p minus 1 under bracket 0. Okay, and we have given p and q non-zero roots. Okay, that means q never possible 0. Q never possible 0. Why q never possible 0? Because in our question we have given p and q non-zero. That means if q is a non-zero and their product is a 0, okay, that means a multiplication of a two term is a 0. Okay, multiplication of a two term is a 0, but one of the term is a non-zero, that means we have here p minus 1 which is equal to 0, and which gives p which is equal to 1. Okay, so value for p is here 1. Q is a non-zero which is given in our question. So we got the confirmation over here that Q is a non-zero root here. Okay, so we have Q which is a non-zero root. So let's figure it out the value for Q by using our these two equation. Okay, so how can we solve this equation further? So P plus Q is equal to minus P. Okay, and we have to find out the value for Q. So take that P here. So we'll get the Q which is equal to minus P, again that minus P. Okay, so minus P means minus 2P. Okay, so I got the value for Q is a minus 2 times P. Okay, so Q is minus 2 times P, and what is the value for P here? So Q which is coming here as a minus 2 times, the value for P is 1 here, substitute it is here. So I got the Q is here minus 2. Okay, so here we can see, as we have quadratic equation x square plus px plus q is 0. Okay, so which is having the value for p is 1 and q is a minus 2. Okay, by using these two result I found the value for p and q, but it is look like it is a unique value. Okay, unicity exists here. So the unique value for q which is exists for our quadratic equation. Okay, and if the equation is quadratic, surely it is having two roots. Okay, and if it is having two roots, then one root goes for the first value p and another goes for the second value q. Okay, so it is easier that you can answer this question by observation only, but if you want the detailed answer, you may see this solution. Okay, so very easy answer it is here. So we want the value for q which is a minus 2. Okay, and which is a unique value for q is a minus 2 that can satisfy our quadratic equation. Okay, and which is given in our option number B. Okay, which is only one value for q it is possible in our solution. Okay, so I hope you all have understood my complete solution. Nothing is difficult here. Okay, very easy question that we have to apply some basic results to find out the roots of our quadratic equation. So easily you can solve this. Okay, so even after if you found anything difficult, let me know in comment section. I will upload similar videos on my channel, and I already uploaded plenty of the videos. Okay, in my playlist all are the previous year question from NDA question paper. So thank you everyone, thank you for my today's lecture.